These are the problems I would like to discuss. So first of all, it is a shaft. I will like to read the question. Knowing that the internal diameter of the halo shaft is 22 mm. So the internal diameter of this one is 20 mm. Outer diameter here given as 40 mm directly. Determine the maximum shear stress caused by the torque of 900 Newton meter. The torque here is 900 Newton meter. So here it is one end fixed. Here we have a shaft. The shaft is hollow, and here we have a torque of T. So T is 900 Newton meter. So here we have to calculate the tau maximum. So here we have only single torque. So you need not to draw the twisting moment diagram. So directly you can solve it. So T by J is equal to tau by R. So tau is maximum you have to calculate. So which you can write it as T R divided by J. T R divided by J. So T here it is 900 into 10 to the power of 3 and considering in Newton mm only. Multiply radius. So radius, maximum radius is 20. So you can write here it is 20 divided by J. J here you can observe the solution also. J is separately written. It is pi to the power of 4 by 32 is formula. So he has written here, but I like to solve here only. That is pi by 32 of outer to the power of 4 minus inner diameter to the power of 4. Outer diameter is 40 to the power of 4 minus 22 to the power of 4. If you solve it, you will get the answer as 78.8. Very simple problem. So next I would like to go with second problem. It is also very third problem. Okay, so it is also very simple. Just observe. Under normal operating condition, the electrical motor exerts a torque of 2.4 kilonewton meter on shaft AB. So it is AB up to here is B. Knowing that each shaft is solid, every shaft is solid, it is a motor, it is exerting some torque over the shaft. And determine the maximum shear stresses. So we have to calculate the shear stresses, tau value. Where you have to calculate first question is tau on AB, so tau on BC, tau on CD you have to calculate. And also you have to observe which one is maximum you have to observe. So for that one, first of all you have to draw the twisting moment diagram. So same thing I like to draw. So it's a torque shaft. Here this point is A, you can observe. So it is fixed. So this torque is A, you can observe. And you can come from one end, this is E. So this is somewhat D, C, and here it is. So the diameter and dimensions you have given, you can observe. So at E, you don't have any torque actually. So E to C, you don't have any torque, it is 0. But at D, you have a torque of 0.4. So one more thing, here you have to indicate it is positive, and it is also positive. So every value you have to consider according to the direction. So if it is positive, you have to take opposite to that one, you have to take the opposite direction. So at D we have a torque 0.4, so 0.4. So this height is 0.4. From C to D you don't have another torque, D to C, so you have only 0.4. But at C, by including this 0.8, it is having some height. The height you can write it as 1.2 because 0.8 plus 0.4 it is 1.2. So again, if you add 1.2 it at a position of B, because this point is B, this point is C, this point is D, this point is C. So here it is 1.2. If you add again, so it's going to be, the height is 2.4. So it is a twisting moment. So here asked to calculate the tau maximum. So it is very simple. Just tau AB you have to calculate. So tau AB formula is TR by J, because T by J is equal to tau by R. So torque at AB is 2.4, but it should be Newton mm only. So kilo means 10 to the power of 3, and meter is also there. So that's why you have to, here you can observe 2.4. So 10 to the power of 3 again. Multiply radius. So radius at AB you can observe AB. The radius is 54 by 2. it is 27. 27 whole divided by j. J is polar moment of inertia. It's pi by 32. Pi by 32. 32 is vector written here. 32 into d to the power of, so what is d? So from here to here d is 54. 54 to the power of 4. So the answer is 77.625 megapascals. So same thing. So from BC also you have to calculate like that only. From CD also you have to calculate like that. So coming to BC, so BC here is 1.2. So 1.2 into 10 to the power of 3 into 10 to the power of 3. So this 10 to the power of 3 is for Newton, this 10 to the power of 3 is for meters. Multiply the radius is 46 by 2. It is taken as 23 whole divided by same 5 into 46 to the power of 4 into 32. So this value you will get as 62.78 into 10 to the power. This is in megapascals. So same thing here is also you had got the value is 20.92 megapascals. So among all these things, this value is going to be the maximum. That's it. So there is a problem. And it is also same similar problem only, but he didn't ask to determine the shear stress. He asked to determine the angle of twist. So the angle of twist you can solve. Same thing. Here is also we have to draw the twisting moment diagram. So here motor is there. Motor means you have to consider that as a fixed one. So here it is A. So here it is B. Whereas here it is C. And this point is T. So both are in same direction. You can consider positive and positive only. From A to B you don't have anything because there is no torque from A to B, but at B you have 200. So it is considered as 200. Height is 200 Newton meter. So up to C it is same. By including C, at C it is 300. By including to the 200 it is going to be 500. So up to this one it is 500. So this is 500. If you read the question, the electrical motor exerts 500 newtons. 500 newtons it is exciting and it is balancing. Right now you can observe the torque on aluminum shaft. So aluminum shaft is ABCD, which is rotating at a constant speed. Knowing that G had given, that is rigidity modulus, and the torque exerted on pull is BC, as shown in figure. Determine the angle of twist B to C, and B to D. So it is a thing you have to calculate. So first of all, I like to calculate theta on BC. So how you have to calculate? Again, you have to use the same equation. T by J is equal to T will be in G theta over L only. So that's why you have to take this equation. So therefore, theta is equal to TL divided by J into G. So same thing, same equation I like to use. So first of all, T in between BC is 200 into 10 to the power of it is in meters. So I'll let you take it 10 to the power of 3. Multiply L. L from here to here it is, you can observe 1.2 meters. So it is 1.2 into 10 to the power of 3 whole divided by. So here J is pi to the power of 4 divided by 32. So pi divided by 32 connect with that, right? 32 here into 2 to the power of 4, that is 44 to the power of 4. Multiply. So here we have a G value is given as 27. So 27 gigapascals here given, converted into megapascals, it is 10 to the power of 3. So the answer for this one is 0.024. It is in radians. So you have to convert into degrees by multiplying 180 by pi. So you will get the angle of twist is 1.38 degrees. Coming to next question, theta B on D. It is also same procedure. But here one thing, that B is here and D is here. So this you can write it as B with respect to C plus C with respect to D. So B with respect to C already we had got the value, so we have to calculate CD. So theta on CD you can write as directly same equation, this equation, that is T between C to D is 500 into 10 to the power of 3. It is a Newton meter, so convert into Newton mm. Multiply the length from CD is 0.9, so 0.9 into 10 to the power of 3 meters again, whole divided by, so pi by 32, so 32 you can multiply here, and pi of diameter at here it is 48. 48 to the power of 4 into G same value, it is 27 into 10 to the power of 3. So the CD value is, so directly I would like to write 0.03198 radians. If you convert it into degrees, so the value is 1.83. So by adding these two values, this value and this value, you will get the answer is, it is 3.21 degrees. So last question, I will go somewhat fast. A shaft is fixed at both ends as shown in figure. So here the diagram is not given. I will like to draw the diagram. So it is the shaft. It is fixed between the two fixed support like this. So let you consider this point is A, this point is D. Here we have a point B. Here we have a point C. So here the shaft is subjected to twisting moment like this. So it is 500 Newton meter, and at C as also we have some other twisting moment. It is 1500 Newton meter. So the length from here to here is L, from here to here it is L, from here to here it is L. So this problem we have to solve. So shown in figure, find the reaction forces at both supports, maximum torque, maximum shear stress you have to calculate. So first of all you have to draw the free body diagram of it. So one end is fixed. So you have to remove one support actually. The procedure for like this problem, so you have to remove one support, and this point is B. B is subjected to 500 Newton meter, and at C it is subjected to 1500 Newton meter. So this point is C. At D you have to assume one torque. So the torque is TD. I'm considering in this direction. You can consider in opposite also. So here it is positive, positive, and negative. So you have to draw the twisting moment diagram. So it is TD. So the height is TD. So it will be same from D to C up to here is same. By adding this one, it is again TD plus 1500. So it will be up to B it is same, but it is in opposite direction. It is going to be less compared to the previous one. But the value here it is TD plus 1000, because it is already TD plus 500 minus 500. TD plus 1500 minus 500 is going to be TD plus 1000. So it is the twisting moment diagram. So one more condition you can use here, that so both ends are fixed means the angle of twist at A and B at A and D both are going to be 0. So the angle of twist is 0. So this condition you can call as a compatibility equation. So theta is equal to, you can take any condition actually. Let you consider theta at D with respect to A. So I already told you this, you can write it as theta D with respect to C, theta C with respect to B, theta B with respect to A you can write. So theta is equal to theta D with respect to C. So from here to here CD. So you have to use the equation, that is theta is equal to TL by Gj, same equation we had used previously. So in this one L is same, G is same, J is same, because L is same for every shaft, and G is metal property, it is constant, and J is also cross section, it is constant in nature. So for that one, so I can write it as L by Gj of all these three things. So I can get directly the TD for this one plus TD plus 1500 for this one plus TD plus 1000 I will get. So which is equal to 0. So finally I got TD plus, this total value is going to be 0. So TD plus TD plus TD, it is 3TD plus 2500 is equal to 0. So TD is equal to 2500 divided by 3 minus Newton meter. So it is a value at reaction at D. So if you substitute this value in at here, you will get the reaction at A also. This is the reaction at A you can get. So therefore torque between CD is equal to TD plus 1500. So just add to it. It is 2500 divided by 3 plus 1500. So the value is 2000 divided by 3. So like that, T B with respect to A, it is again TD plus 1000. So TD already we had got 2500 divided by 3 plus 1000. The value here it is 500 divided by 3. So these are the reaction forces. So it is a reaction force at A and it is reaction force at T. So coming to the second question. Second question is maximum torque. So let us consider the first question. So first question answer is these two red colors. So second question answer is among these three things. So 2500 by 3 is the maximum. So TD it is the maximum torque you are going to get. So coming to the third question, because second question he asked only maximum torque you have to mention. So that's it. So third question you have to calculate the maximum shear stress. Maximum shear stress is possible by TD only. So therefore tau is equal to same equation. It is T by J into R. Okay. So T here is 2500 divided by 3 multiply R. R you can write it as diameter head mentioned as 15. So 15 by 2 1 by J. J is polar moment of nature. It is pi d to the power of 15 to the power of 4 divided by 32. So here I can write 32. So the value is 1257.5 megapascals. So that's it. It is the procedure you need to follow. So like that we have another question. So just I have written here. Just go with it. I like to end this session because most of the torsion problems will be like this only. Just better to go.